Janice, over to you.
Thank you, Momita, and good evening, everyone. Our first speaker, Professor Padmanabhan Balaram, is a well-known Indian biochemist and the former director of the Indian Institute of Science, Bangalore. He is a recipient of India's third highest civilian honor, the Padma Bhushan. It's an absolute delight to have you here with us, Professor Balaram, and I hand over the session to you for sharing your thoughts on Professor Subbaiah Arunachalam, scientometrics, and the open science movement. Over to you, Professor.
Before I share my thoughts, can I share my screen?
It's there, but yeah, it's now on full screen.
Okay, thank you. My apologies for this slight hiccup. You know, when I was invited to speak at this meeting marking the Open Access Week, I was reluctant because I don't have very much to say on open access. But then when I was told that you were also honoring an old friend of mine, Subbaiah Arunachalam, I said I would of course speak. And therefore what I've chosen to do is to speak a little bit about Subbaiah Arunachalam, scientometrics, which he brought to India, and a little bit about open access. This slide of mine is really my acknowledgements. All my interest in scientometrics began in the library of the Indian Institute of Science when I was young. When in the mid-1970s, I used to read Eugene Garfield's Current Contents, and I would read the column that Garfield wrote week after week. And then over the years, I came to know Arunachalam, and then I came to know two other people who are also pictured on the slide, so I would like to acknowledge them. Ratnakar, who was also from the library and information science community, and Satyanarayana, who also began in the Indian Institute of Science. All of them began in the Indian Institute of Science. So in a way, today's talk is a tribute to Arunachalam's contributions in bringing scientometrics to India and then being a tireless advocate of the open access movement. Garfield, whom one could well regard as the founding father of the field of scientometrics, although there are others, wrote this famous paper in Science in 1955. I would only like to read you the second part of his title, which says, "A New Dimension in Documentation through Association of Ideas." This is what attracted me to scientometrics, because you could now trace the association of ideas. And Garfield introduced the idea of what he called the historiograph. Citation indices today are more misused than used, but I'd like to show you some ways in which Garfield used them. In 1984, just after the 1980 Nobel Prizes had been announced, Garfield wrote an essay, and he described the physics prize, which went to Subramaniam Chandrasekhar that year. So all of us in India were very happy to read the essay. Garfield also did an analysis of Chandrasekhar's papers, and eventually in passing noted that he had also worked in the field of liquid crystals. Sometime later, in February of 1985, he published a correction note. And there he says that he mixed up two S. Chandrasekhars. One was Subramaniam Chandrasekhar, the astrophysicist. The other was Shivaramakrishna Chandrasekhar, the liquid crystal physicist. Both of them were very important scientists. And this mix-up happened. But then in the correction note, this is what he says. Our diligent colleague and correspondent in New Delhi, S. Arunachalam, editor of the Indian Journal of Technology, not only called this error to my attention, but he also correctly points out that the total citation counts for these two gentlemen were probably merged. And this was true. Arunachalam in the mid-1980s must have been one among the very few people to look at all of this so carefully. Sometime later, in April of 1986, Garfield published another essay which I read in the library of the Indian Institute of Science. This was entitled Mapping Cholera Research and the Impact of Shambhunath Day of Calcutta. He had spelled Day's name wrong, but nevertheless, it was the first time I'd ever heard the name. And then here it was, Garfield writing about him and saying that his work had had a fundamental impact on cholera research. I remember at that time discussing this with Arunachalam. And then Arunachalam told me that in a visit that he'd made to the National Library of Medicine after this had appeared, he'd actually seen a letter in the Joshua Lederberg archives in which Lederberg had apparently nominated Day for the Nobel Prize. Garfield goes on to write in his essay that there are parallels between Barbara McClintock, the 1983 Nobel Prize winner, and Day. They were both prone to seclusion and intellectual isolation. So I was intrigued by Day, and then when a couple of years later I joined the journal Current Science, the then editor, Professor Ramaseshan, suggested that we do special issues because the journal had fallen into bad times and did not get enough articles. I chose SN Day as the subject of the first issue, and this was in the year 1988. I knew nothing about Day, I knew nothing about cholera toxin, but with the leads that I had and with Arunachalam's encouragement, I began to write to people. The first person I wrote to was Joshua Lederberg, and I asked him whether he would write an article for this issue. I was also naive at that time, so I asked him, did you nominate him for the Nobel Prize? He wrote back a very gracious letter saying he would of course write, but he didn't answer my question on whether he had nominated Day for the Nobel Prize. But this told me that Day was very highly regarded by biologists abroad, especially those working in the field of cholera. So when I began to write to all of them, they all responded and we produced this issue. We also discovered that Day had been invited to a Nobel Symposium in 1978. And this was a symposium many, many years after he had retired in his late 1950s. He makes these remarks in that symposium. He says that I wish to make a few personal remarks. I've been dead since the early 1960s. I have been exhumed by the Nobel Symposium Committee. And so I was very excited to include this in the special issue of Current Science. I wrote to colleagues of Day, his friends who had helped him, and then they wrote an article about him. And this, they say, he died on April 15, 1985. A few hours before his death, when he was in a state of coma, a letter arrived from S. Arunachalam, editor Indian Journal of Technology, requesting him to get in touch with Eugene Garfield, who was interested to know his biodata and professional contributions. Day could not be informed about this. This terse conclusion tells us something about the sad story of SN Day. It also tells us something about what scientometrics can sometimes do. It can exhume from the dead people who have done wonderful work. But today's literature looks like this. It's what Nature called in 2014 a paper mountain. If you just take the first page of every paper that's been published till 2014 and stack them up, it will reach the height of Mount Kilimanjaro. And of course, along the y-axis here, you can see the number of papers which have never been cited, the number of papers which have been cited from 1 to 9 times, and those which have been cited 10 to 99, and the superstars which go much higher. Why do I show you this? Because scientists are animals who like to write papers. And I've just paraphrased Lewis Carroll, who said that the proper definition of a man is an animal that writes letters. The most highly cited papers, the superstars of the scientific literature, are almost all in biochemistry, and a few others in theoretical chemistry. This is largely because it's methods which are cited most, and the biomedical literature is the one which has the largest volume. So using citation counts without understanding disciplinary differences is something that one should not do. But why do we have so many papers? Why don't we just have the best papers? Garfield asked this question in 1970. He said that the growth of science is dependent upon an accumulation of many mediocre results that are produced by hard work. He, of course, put mediocre in quotes. And then he said, long live the mediocrities. Without them, how could they be geniuses? 40 years later, in this article in Current Science, Arunachalam and his colleagues, Madan and Chandrasekhar, wrote this article. They were analyzing publications from India and China. This was at a time when China and India did not have such a large gulf in scientific output as it is today. And when they did this analysis, they came to this conclusion. They said it's heartening that the production of research papers is increasing in India and even more so in China. And then he says, the next step is for researchers in the two countries to write papers that will be cited far more often than now. But what attracted me to this article was this quote. They quote Chairman Mao. Not many people quote Chairman Mao. And they say every quality manifests itself in a certain quantity, and without quantity, there can be no quality. This is in fact true. Without volume, it's very difficult to find those exceptional pieces of work. There have been many other analyses in the years afterwards. In 2018, this interesting analysis appeared in Nature about scientists who publish a paper every 5 days. This is because of the corporatization of science, where a single scientist, here resembling an octopus, can now collaborate with people in 20 different laboratories and have a paper which has 100 co-authors. This has been well illustrated in many of the papers which have appeared during the COVID pandemic. But scientometrics has also led to what I would like to call the metrics obsession. And recently there was a paper in PLOS Biology which has had a wide discussion in India. And this is largely because the authors come from Stanford, and the Stanford brand now lends respectability to anything that is written from there. But when you look at a formula like this, formula for calculating the career-long impact of a scientist, and you have an equation like this, you then really begin to wonder about the directions in which scientometrics has gone. It's no longer looking at what Garfield called an association of ideas. If one wants to give a talk today, and I have given them, one might discuss scientometrics and science publishing. I would then add the subtitle, The Corrupting Influence of the Marketplace. Or one could talk about modern science publishing. It's really an enterprise which is driven by two attributes, greed on the part of the publishers and vanity on the part of scientists. And the cartoons that I have here really illustrate the problem. Greed, of course, it turns out, because if you look at this statement a few years ago, Elsevier's profit margin was 36%. It was higher than the profit margins in 2010 posted by Apple, Google, or Amazon. And of course, publishers would like to maximize profit, and this cartoon summarizes it well. It turns out that the public hates the culture of corporate greed. And of course, within the boardrooms, they will say, let's figure out how we can monetize that hate. And that monetization of hate has happened because of the takeover or the hijacking of the open access movement by commercial publishers and societies which have now teamed up with commercial publishers. So today you pay and publish in mainstream journals, you also pay and publish in predatory journals. But the sad state of scientific publishing can be traced back to Robert Maxwell. And I found this rather interesting review of a book on Robert Maxwell which appeared earlier this year. It says it's very easy to see Maxwell as a forerunner of Trump. And in many respects, Maxwell was a brilliant businessman. Says the author, he became the world's largest, most successful publisher of scientific journals in the 50s. and that didn't happen by accident. He purchased Butterworths in 1951 for £13,000, sold it to Elsevier in 1991 for £440 million. And Maxwell should be best known by this wonderful quotation. He said, "Science publishing is a perpetual financing machine." He introduced the Letters Journal in Organic Chemistry, tetrahedron letters in those days, 2-page communications which the authors typed and which was photo offset. It turned out that on his 60th birthday, even the most distinguished scientists in the world, Carl Gerasi here, dedicated their papers to the founder and publisher of Padmanabhan. It would be nice if you muted your mics. Vanity is, of course, on the part of scientists. And in the days after Maxwell, journals have appeared in the 70s, first from MIT Press, Cell, which then became Cell Press, in 1999 acquired by Elsevier. Benjamin Levin, whom I picture here, has been described. He was very clever. He realized that scientists are very vain and wanted to be part of this selective members club. Cell was it, and you had to get your paper in there. He's quoting Randy Sheckman, a Nobel laureate who has now started a journal called eLife. Again, it's a club and everybody would like to get into it, and you have to pay substantially to get your papers published there. In the proceedings of the National Academy of Sciences, the very prominent neuroscientist Solomon Snyder had an article with this title, "Science Interminable, Blame Ben," because he exhorted authors to refrain from publication until they completed their stories. The result is modern cell biology and molecular biology has papers which have an immense amount of data in them. They take years to put together in order to get into these journals. Very often it turns out that there's a very high retraction rate in these journals. And very often you will read this, that such and such a figure which has been doctored or which is wrong is not important for the conclusions of the paper. Then, of course, one wonders, why was it in the paper in the first place? This is because of the demand for what is called the complete story. So in science publishing, Robert Maxwell invented the least publishable unit in the 1960s. And the deluge of data and the illusion of the complete story was invented by Benjamin Levin in the 1980s. There is now, of course, what I would call the subversive role of paid open access. The commercial publishers, including those started by very prominent scientists, the PLOS group of journals, which started in 2003, these were doomed to the state they are in today, journals which make money. They are journals which are out of reach for scientists in most parts of the world who can't afford to pay and publish. When Arunachalam was a tireless open access campaigner many, many years ago, we were talking about a different kind of open access. We were talking about institutional archives where people would deposit all their published papers and they would then be available. They would bypass the copyright laws and so forth. But today we have hybrid journals where authors pay to publish and readers pay to read. We've also had the rise of the open archives. So you don't need institutional archives anymore. With search engines and so on, you can get into all these. The physicists had it first. The biologists came later and the chemists came in last. But if you look at ChemArchive, it's now supported by ACS, the Royal Society of Chemistry, and the German Chemical Society. All of them are now commercial publishers. And therefore, I would say they are in fact subverting the open access movement. Today's paid open access journals are both supposedly respectable and also designated as predatory because they don't have peer review. Author career advance requires peer review, and therefore archive postings are now only for establishing priority claims. This cartoon sums it up all. When you talk about archives, physicists may say we've been doing it since the 1990s and nobody seems to care. And that's the situation with archives. We also have the pirate sites, which are the only sites where people from developing countries go to for the scientific literature. That is Alexandra Elbakian's Sci-Hub. This, of course, is a kind of Robin Hood approach. And the pirate servers now serve as the only source of information for very large numbers of PhD students in India, across India. And as I conclude this presentation, I will tell you that there is an ongoing court case now being fought in the Delhi High Court. And this court case pits Sci-Hub, and that's the founder of Sci-Hub, there against these three gigantic publishers here. You have Elsevier on the one hand, Wiley, and the American Chemical Society. It's a sad state for a scientific society to join with the commercial publishers to block access to the scientific literature. In paying a tribute to Subbaiah Arunachalam, I must say that he is the man who really tirelessly promoted open access in India. And when he brought people like Stephen Harnett and Peter Suber, Leslie Chan and others to Bangalore, we were in fact at that time thinking of a utopian idea for open access. But I now realize that the world of scientific publishing is dominated by commercial interests, which are fueled by the culture of the scientific enterprise itself. Unless these change, we will celebrate Open Access Week year after year, but access to scientific information will still remain an impossible dream for most people in the poorer countries who are trying to do scientific research. Thank you very much.